Hello friends, today we are going to see the question number 2 of this Codemonk Java and Python full stack engineer hiring challenge, which is present on Hackerearth. This competition will run till 23rd October. So we are going to solve its second question, valid subset. So the question states that you are given an array of size and a valid subset of A is one in which the bitwise XOR of all the elements is equal to the sum of all elements. So we can say that if we have an array like this 0, 1, 2, 2, and if we have some subset of this array like 0, 1 is a subset of this array, then we need to find it bitwise XOR and sum. So bitwise XOR of 0 and 1 is 1, and sum of 0 and 1 is also 1. So if both these are equal, then we can say that it should be part of our answer. If A equal to B, then it will be a part of our answer. So we have to find the count of all these subsets. So, and we have given that count might be a very large number, so we can print its modulo to 10 ki power 9 plus 7. Let's take an example. If n equal 3, a equal 1 to 3. So we are given an array 1 to 3. Total number of elements in an array is 3, and then valid subsets are single element is always a valid. Why? Because its sum and its XOR is equal to this element only, and 1, 2 XOR is 3 and sum is also 3, so it is also a valid. 1, 3 1, 3 its sum is 4 but XOR 2, that's why it is not a valid. Likewise this. Now we can understand how we can approach this problem. Like in this problem we have to find all the subsets, and then we have to check whether the subset following our condition or not. So finding all the subset of any given list, we can do it using recursion. So first we can see the recursion approach to solve the problem. So we are taking find all subset method, and then we are taking one list having value 1 to 3, and now we are passing this here. So for finding whether this so for finding whether this has a valid, this function has a valid subset or not, what we are doing, we are using the recursion. In recursion we are passing I, A, sum and XOR, because we have to store the sum of previous traversed element of the array, whether it is taken or not. If it is not taken, then it is not added in the sum, and it is not processed in XOR, or if it is added, then it should be. So our base condition should be if I is smaller than 0, then we have to return what we have to return. We have to return 0, and whether we take any element or we did not take. So we have two choices, whether take element or did not take. So if we are not taking the element, if we are not taking the current element in our subset, then we should decrease the I, and we have to return the same element. If we are taking the current element, then what we need to do, we have to take this element and then update the value of sum and XOR. So what we are doing, we are adding a of I here and doing XOR from a of I, and here we are checking if XOR equal to none, then XOR equal 0. If sum equal to none, then sum equal to 0. Why we are doing this? Because we are passing here length of a minus 1 comma a comma none. Because for 0, if we are passing here 0, then it will count one extra 1 in the answer, because for no element 0 is equal to 0. And here we are adding, here we are checking if sum equal to XOR, then return 1. So if we are not passing none, then if we are not taking any element, then 0 is equal to 0, and then it will return 1. And for case if we have only one element in the array, then it will return 2 as an answer. It is wrong, because we have only one subset, that is 0. Now we have this condition. Now we have to return a plus b. Here we can return this function. Now we can recheck once I a sum XOR. If I is smaller than 0, return sum equal to XOR, return 1, return 0. A equal find I minus 1 a sum XOR. if XOR equal none, XOR को 0 से इनिशलाइज कर देंगे, देन सम को 0 से इनिशलाइज कर देंगे. हमने I को घटाया a, एंड सम में हमने a of I ऐड करा, XOR में हमने a of I को XOR करा, देन हमने रिटर्न कर दिया इन दोनों का आंसर. यहाँ पे हमने अपना मेन मेथड कॉल कर लिया, इसमें हमने a पास करा, यहाँ पे आंसर है, यहाँ पे हमने आंसर प्रिंट कर दिया. लेट्स सी. So here we did a small mistake. We put 3 equal sign instead of 2. So we are getting here 5, and its actual answer is 4. So we are getting wrong output. Why? We need to check it. And here we need to say if sum does not equal to none and XOR does not equal to none. So we have to update our condition, then we are getting the correct answer. For this input we can test again. Yeah, so we are getting the right output. So we need to put this condition also. So we have to return the answer modulo 10 to the power 9 plus 7. So we are creating m equal 10 to the power 9 plus 7 here, and every time we are returning modulo m. So this is a recursion way to solve this question. Now we can see a dynamic programming method to solve this same question. Now we are going to see the dynamic programming method to solve this same question. I am creating new function for DP implementation with same parameter a. So as we can understand from this above implementation, there are two ways for any to understand the any element contribution, whether it should contribute or it shouldn't contribute. And we know that, like, if the element is contributing, then we have to check particular condition, if it's actually contributing in answer, if sum of a sum plus a of I equal XOR of a of I. So from looking this recursion function, we have some doubts initially whether we have to create 1D DP, 2D DP or 3D DP. So I am clearing your doubts. First, we have parameter I, which is very necessary for this dynamic programming implementation. For every element we need to process it. And second thing, we have sum and XOR. There are two another parameters. So can we reduce any one of the parameter and we can create only 2D DP instead of 3D DP? Yes, we can. How we can? Because we know that in our given question it is given that we get the answer only when we have sum equal to XOR. Only that if this condition true, then we get the answer. So we can easily assume that all values of sum, if it is equal to XOR, then we have to get the answer. So we do not need XOR anymore. And why we are not choosing XOR instead of sum? Because we know that sum of series is always greater than XOR of any series. So we are creating one DP function, and first we are finding the length of A and sum of elements of A. Now we know that every element contributes itself in an answer if it is alone, because a single element is always its XOR and its sum is always equal. So we can do this here. DP of I comma A of I always be having value 1. Now if we are not taking, then we have to simply go to I minus 1 and sum if I minus 1 is greater than equal than 0, else 0. And for B we need to go dp of I minus 1 and sum minus A of I if sum, if here J, our current sum is J minus A of I, if and only if when J minus A of I is greater than equal than 0 and J minus A of I equal to J XOR A of I. Else 0 dp of I comma 0 plus equal 3. So let me clear all your doubts. If you're thinking why we are returning sum of dp of -1 and what we are doing here, so I implemented this function. Now I will explain what's the logic. So code logic is, first we are creating the 2D dp of n rows and some plus 1 columns. Why we are doing this? Because we know that we have n elements and maximum possible value of XOR or sum is sum plus 1. Now implementation is complete for this dynamic programming method, so I can explain you. So first of all, we are creating one 2D array in which we have number of rows is n and number of column is sum plus 1, because maximum of XOR and some value is sum. Now for every, we know that every element is also contributing in answer, because for one length element it's XOR, and for one length list is only one element is present and its XOR and its sum is both are equals. So we are initializing for those value and we are putting dp of I comma a of I equal to 1. Now we are running one loop from I equal 1 to n and some from, and another loop from for j in range sum plus 1, 0 to sum plus 1, because for every element I we need to check for current value of j. If we are taking this j value, if for this particular j value and for this particular I value, we have two choices. Either we can take this I value or we can't take this value. If we are not taking this value, then we have to simply go to the previous row and find the value for same j. And if we are taking this value, then we are subtracting a of I, and we are taking this value only when if our this condition satisfy, and this condition is j minus a of I equal to j XOR I. We are placing minus here instead of plus, because with if we are standing at a particular position for element j, and we think this sum is made up of after adding current element value. So is j equal to x plus a of I. X is the previous value and we are adding a of I, then it becomes j. So for finding the previous value, which is actually equal to the previous XOR, so we are simply we are doing simply j minus a of I, and then again doing XOR j of XOR of a of I, and if this condition satisfied, then we are simply adding a and b and finding the modulo. So this is our final implementation, and its time complexity is n into m, where m is n into, here its time complexity is O of n into m, where n equal total number of elements in array, m equal sum of all in array. Thank you friends.